Okay, now in this recording, sizobe discuss our own ways to apply the Euclidean geometry theorems, all the theorems from theorem 1 all the way up to theorem number 9. So I'm assuming we awazi lama theorems by now. So nangaba awazi, please check them out before uzala, before ubukela le video le. Make sure ukuthi uyawazi lama theorems from theorem 1 all the way up to theorem 9. In the description box ngishare ama links for all those theorems which engwa recordile in this channel, so check them out. Unama exercise futhi ongawa attempt as well. So lana we are discussing ways to apply lama theorems wethu. Wa apply makwenze njani, why you apply theorem 1, why you apply theorem 2. So into so discuss la. Yes, okay. Now astalling lama theorems lawa, all the theorems involving ama centers, like asos nama theorem sai 9, all the theorems anama cases where swa apply khona. For instance, theorem 1, 2 and 7 sba apply whenever we are given a center of a circle, right? There are other theorems eswa apply nangabe basinikeza a cyclic quad. Unamanye ama theorems eswa apply nangabe basipha a tangent. Yabona? Unamanye ama theorems eswa apply nangabe basipha a diameter, right? So sizo discuss those cases ukuthi theorem 1 apply uma kenze njani, theorem 2 apply na kenze njani, theorem 5 apply uma kenze kanjani, uma kenze njani. So all the theorems are involve ama centers with theorem 1, 2 and 3. Whenever you are given a center, always look for always look for ways to, or expect to apply theorem 1, 2 or 7. It's not like lama theorems 1, 2 and 7 uzowathola won't get once whenever they mention a center. No. But what I'm saying is lama theorems lawa will apply whenever you are given a center. Look for theorem 1, 2 and 7. Right, now my theorems way together. Theorem 2, theorem 2, theorem 2. These are the 3 cases of theorem number 2. Theorem 2, whenever you are given a center, expect to apply theorem 2. Whenever you are also given a center, always expect to theorem 1. This is theorem 1 as well as the converse of theorem 1. I expect to apply theorem 1 as well as the converse whenever you are given a center, as well as with theorem number 7. The radius is always perpendicular to any tangent. So here's another special case. This is a special case where you are given a center and then nama radius. So ngina 2 yama radius, 1, 2 as well as a line between these 2 radiuses, so form a triangle. By the way, this is an isosceles triangle. So expect to apply the ideally. So this idea basically sokuthi lama angles lawa aya lingana lama ideas lama angle lawa, right? So this is another special case esitholai whenever we are given a center as well as a radius. So from a question paper perspective, this is what you might expect. Now, okay, lana bangiphe center na center lapha, center O. Uma ubhekile kuno theorem bani la. Kuno theorem bani? Mina ngibona theorem 1. This is theorem 1. Line from center bisects chord. It bisects this chord. It bisects this chord. So this is theorem number 1. Theorem 2 no theorem 7 simboni la, but for the fact that we are given a center, now with theorem 1 we are valid. It's not like every time gune center you value theorem 1, 2 and 7. So expect ukuthola theorem 1, 2 or 7. Hayi wonke. Sometimes ungawathola wonke, sometimes angeke uwathole wonke. Okay, now asimuvele to amanye ama cases ke manje. Na enye case ke, theorems involving ama diameter, which is only theorem number 3. Theorem number 3. Now, if AOB is a diameter, then angle C is equal to 90 degrees. So this is all about the theorem bani, theorem number 3. Now theorem 3 bangipi diameter, this angle is always equal to 0. This angle is always equal to 90 degrees. This is an angle in a semicircle. So na example lesingayithola ke la. Here's an example lesingayithola. This is a question paper example where we are given a diameter la. Na diameter in a triangle la. What can we say ngale angle yala? Ngale angle yala, of course it's 90 degrees. Or nanga uyayibona lenye diameter le. Mina ngibona enye diameter na la forming this triangle le. It means what? Okay? This whole angle is what? It's 90 degrees. Oh yes, it's 90 degrees. Right? It's 90 degrees. So now about 90 degrees, about 2 in this case. It's not like now one out theorem number 3 value you apply no. You need to ngathi lama theorems akunceda ukuthi uphendule lama questions la. Yabona? So for instance, theorem number 3 angasincedisa ukuthi isicalculate ubani uq1, but more about this later. I've also left a link for ama exercises engiwayenzile for where I apply wonke lama theorems in under exercise A1. Check it out as well. That's where you discuss more of ama applications of the theorems. Yabona? So check it out. So theorem 3 nyambona like question nangu 90 nangu 90. So basically lama theorems asinceda ukuthi sicalculate siphendule lama questions, right? So adinga to apply your own thinking. Just think of ways to solve lama problems law using lama theorems law, right? So angeke bathi kuwe calculate to angle P bese apply theorem 3. No, sometimes ukufuna ukuthi ucabanga. Check bheka leyo exercise engiphendulile lapha in the description box. So now my theorems are involved in diameter. It's theorem number 3. Okay. Now as begin now my theorems spelling something wrong la. Theorems. It's theorems, not theorems. Theorems involving ama cyclic quads. I2 with theorem. Okay, the spelling is totally right la. Theorem 5 and 6. Theorem 5 and 6 are involved in ama cyclic quad. So whenever you are given a cyclic quad, expect to apply theorem 5 and theorem number 6. It's not like every time now thola Euclidean geometry problem you apply wonke lama theorems. No. You look for lama keywords. I'll give you a summary nangiceda ngale video lena ukuthi nabakuphi question what to look for. Yes. So lana ke theorem 5 and 6. So theorem 5 yambona mina yambona theorem 5 la nang theorem 5. This is theorem 5. Theorem 5 ama opposite angles angle A nangimhlanganisa no angle C, I should get 180 degrees. B no D, B plus D, I should get 280 degrees because of angles in a opposite angles in a cyclic quad are supplementary. And then lana it's theorem number 6, angle 2 is equal to angle P. This angle is equal to this angle, external angle of a cyclic quad. And then here's another case again. Here's another case where the angle A is equal to this one. Angle A is equal to this one. So Lena, it's in a way, even this one it's equal to this one is also equal to this one. So in a way, the theorem it's sort of like a mixture ka theorem snatin. Okay, involves a cyclic quad, but it also involves with theorem number 4. Theorem number 4, because of our angles in the same segment, but swathola ngaphakathi kwani go cyclic quad. So expect whenever you thola a cyclic quad, look for these cases. Always look for these cases. All right, now a question paper example. So lana basiphe a cyclic quad. I think thole a line la. Basiphe a cyclic quad. Nice cyclic quad here too. This is our cyclic quad. Boom. Therefore the angle yonke le, this angle Q is equal to this angle. We have what? Theorem number bani, theorem 6. So lana it's 48. It also means lana so to subanobani no 48. So lama theorems, they just help you out to calculate or answer lama questions about buza wona lapha, right? So now lana inte, oh yeah, another thing in we mention la, especially theorem number 5, theorem 5. Usually theorem 5 uzom apply if bakuphe ama values wama angles la, mhlambe bathi 70 degrees la, calculate to angle D, therefore ungakhona uku-apply theorem number 5, right? Or bangati prove that this shape is a cyclic quad, therefore wenzani apply theorem number 5, but make sure ukuthi bakupha ama values la. Usually theorem 5 sim apply in such a case where they give you values inside your cyclic quad, right? Okay, now let's move to amanyama cases again now. All right, now my theorems involving ama tangents. That's theorem 8, 7 and 9. Theorem 7 sekavela kwesi2 simthole nakuphi kuma theorems are involve ama centers, but nala kuma tangents yamthola. So theorem 7 nangu ke la, I mean ama theorems are involve ama tangents. So this is theorem 7. Tangent perpendicular to any radius. Theorem 9, tan chord, the angle le is equal to this angle. This angle is equal to this angle. This is the acute angle case. Yellow guy, I got theorem 9. Check it out. You discuss theorem 9. I'm checking in the description box. Now about our understanding nangithi acute angle case, and then an obtuse angle case. Now this angle is equal to this angle. This angle is equal to this angle. This is the obtuse case, the obtuse angle case, as well as with theorem 8. Tangents from the same center. So ama theorems are involved in ama tangents now, right? So far sikhulume ngani theorems involving ama centers. Sabuya sakhuluma ngama theorems are involve ama diameter. Sabuya sakhuluma ngani ngama cyclic quads. Now sesikhuluma ngani ngama tangents, right? Sesikhuluma ngama tangents again manje. Sesikhuluma ngama tangents. Now for the last one, theorem 4. Theorem 4, theorems involving ama chords, right? Chords. I don't like using the word chords, but ngithanda ukusebenzisa the word bow tie ngoba theorem 4 is best described by legama leli, bow tie. A bow tie, uyayibona mos, nangabuthola something like a bow tie, so expect to find ama angles in the same segment. Nangabubona bow tie, expect to apply theorem 4. So le equal to this one equal to this one, right? So now amanye cases as well. Now amanye cases. The reason why ngithi ama theorems involving ama chords, it's because of these two cases now. These two cases. Lama chords, equal chords are subtender ini ama equal angles. The chord le equal to this chord, but in different circles. Lama angles lama chords lawa equal, they subtend equal angles. That uyabona uma sibona, okay, let's move away from the bow tie sangena kulama equal chords la, uyabona. So the reason why sibiza ukuthi theorems are involve ama chords, it's because of ama equal chords. But to theorem 4 is what's the right word, Maral? Theorem 4 is characterized by a bow tie structure. So na a bow tie, nangabubona a bow tie, expect to apply theorem 4. Nangabubona ama equal chords, again it's still theorem bani 4 ngoba ama theorems are involved ini ama chords. This is a bow tie na in ama chords now, A B chord no C D chord, right? No C D chord. So now agama theorems wethu. Na example la na bow tie. Mina ngiyayibona bow tie la. Na bow tie. Nangabe uyayibona bow tie, just make sure ukuthi there must be a way you go apply khona la. Right? Nangabe uyayibona bow tie, expect to apply theorem bani 4, which is okunceda ukuthi uphendule lama questions ababuza wona la, right? And then here's a bonus one again. Here's a bonus. Alright, now bonus again. There are special cases again where you are given ama parallel lines, none. Okay, ama parallel lines nalama special triangles now, right? So whenever bagupa ama parallel lines, whenever ubona a parallel line, expect to apply ama alternating angles. The angle le equal to this angle. Amanye ama alternating angles uyawabona, mina ngiyawabona now. Le it's equal to this one. Ama corresponding angles now, right? Corresponding angles now. Amanye ama corresponding angles uyawabona, mina ngiyawabona now. Amanye now they are equal, right? Ama corresponding angles. And then co-interior angles. Co-interior le angle le, now you add another angle le, you should get 180 degrees. And then we go about my isosceles triangles. Here's an important one. External angle of a triangle. External angle of a triangle. The angle le C1. C1 is equal to angle A plus angle bani B. Enye theorem ezokhipha emahlathini ke le. Sometimes unokikirizana ne problem uboka ukuthi theorem 1 akasebenzi la, theorem 2 akasebenzi, sengizame konke. Try this thing izokhipha emahlathini ke le, right? Even this one iyanceda kakhulu. Remember lapha kuma theorems involving ama centers, a center, radius. Ama radius they are equal, so le equal to this one, and then uthola a line in between la. Lama angles lawa are equal. Izokhipha emahlathini na this one. And then for the last one yini equilateral triangle. So whenever ubona these special cases, make sure that you apply for parallel lines, apply lama corresponding co-interior, and then for ama triangles you apply these things. So check out the exercise engiyenzile concerning all wonke lama theorems. When pendula in exercise, when apply wonke lama theorems under a problem A1, ama numerical exercises uzobona ukuthi ngikhuluma ngani kahle kahle. Check it out in the description box. Now special cases, this is the last one. Okay, I think kuphe summary nyana. I think he summarize this thing la. Basically things ebengizama ukuyisho la ukuthi asho nokubona nabakupha a problem, whenever bakupha a problem a Euclidean geometry problem baqala bakupha i-statement lapha, and then bakupha le structure sakhona, bakupha le circle yakho, and then bese bathi kuwe calculate to q1, calculate to n1, calculate to ql something, what. Kule statement sakho make sure ukuthi you look for the following keywords: diameter, 2, you look for what again? Center, you look for the word center. Number 3, you look for another word, what's this one? Cyclic quad. Sometimes abakutshela ukuthi this is a cyclic quad, wena kwamele wazi ukuthi lento le cyclic quad. A cyclic quad uyibona ukuthi it's just it's a quadrilateral inside a circle, 18 times circumference 4 times. This is a cyclic quad. There's no need ukuthi ngikutshela ukuthi this is a cyclic quad. Uyayibona ukuthi cyclic quad ngoba ithinta kayi 1 2 3 4 inside the circle. So cyclic quad. Number 4 bese kuba yini futhi? Okay, diameter, center, nama tangents, as well as what? Okay, chords now. Chords now, there's no need ukuthi ngitshele ukuthi this is a chord, but uyayibona, or let me say chord / bow tie. As izinto uyazi-observe, you don't need to be told. Uyazi-observe, uyabona kune bow tie, kune chord la, bow tie nazo ke. So lama keywords lawo: diameter, center, cyclic quad, tangents, chord ne bow tie, yiwo lamagama akutshelayo ukuthi kwamele ngi-apply maphi ama theorem. So basically this was the discussion, this was the message ebengifuna ukuyi-convey in this video. So yeah, iphelela lana guys. So these keywords yiwazokutshela ukuthi apply maphi ama theorems. Usually you find these keywords kuphi statement sakho before uzosolve a problem. So video yethu iphelela lana. I hope you enjoyed. I hope uthole some value out of it. Ungakhohlwa ukulike, ungakhohlwa ukushare, ungakhohlwa ukusubscribe. In the description box there are videos which I find useful, so ngwalink in the description box. Please check them out as well. Azokunceda kakhulu in understanding Euclidean geometry much better. So for now, asibonane on the next video. Bye bye.